everybody. We're getting ready to do lesson 19 of SAT Math Level 2 Prep. And for today's lesson, you got 10 points in your notebook. And 28 points will go into your classwork sheet. Name, date, period, students, due date for my online. And we go right into page 1 here of our lesson. A sequence is a function with a domain that consists of the natural numbers. A series is the sum of the terms of a sequence. So here's our difference here between a series and a sequence. So knowing that, we go right into an example here. Let's get right into it here. So examples, we have an infinite sequence. So an example of an infinite sequence would be this here. 1 over 2, 1 over 3, 1 over 5, blah, 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 1 over n plus 1. So we add 1 to each one of our values of our denominator. Is an infinite sequence with our term 1 here is 1/2, term 2, term 3, term 4, to term n, which equals 1 over n plus 1. So that would be an example of an infinite sequence. B, a finite sequence. So an example of that, 2, 4, 6, 20 is a finite sequence with term 1, 2, 4, 6, then term 10 would equal 20 there. And then an infinite series. So instead of a sequence, this would be an example of an infinite series. They go 1/2, 1/4, blah, 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 1 over 2 to the nth. Plus blah 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 is an infinite series. So this is a series here. Juxtaposing that to an infinite sequence, an infinite series here, 1 over 2 to the nth here, and this is 1 over n plus 1. So that would be your difference here. Would be an infinite series. And then if term to the n equals 2n over n plus 1, find the first term, 5 terms of the sequence. So again, we're dealing with sequence here, not a series. So when 1, 2, 3, 4, and 5 are substituted for n, we get term 1, term 2, term 3, term 4 equals finally 8 over 5. Term 5 equals 10 over 6, which would equal 5 over 3. So the first 5 terms are 1, 4 over 3, 3 over 2, 8 over 5, and 5 over 3. So that would be how that would go. And then examples A through D, formulas were given for finding each term of the sequence. So another way of specifying a sequence provides a formula that gives each term as a function of its predecessor term. So that's the difference there of a sequence. So it's depending upon its predecessor. Examples E and F illustrate this method. So this was our finish here on D, was this up here. And a sequence is dependent upon its predecessor. A series is the sum of the terms in a sequence. So a series is a sum. It's not the sequence. A sequence just lays out the numbers from its formula. The expression of summation of n and then I equals 1 tk represents the sum of n terms beginning with t term 1. The lower limit of the sum shows the starting point, in this case 1. Here's your starting point here. And the upper limit is the ending point, in this case n. Each tk represents the kth term of the sequence, so k equals 1, 2, blah, 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 up to n. Okay, knowing that, let's go into an example here. If a1 equals 3 and a to the nth equals 2a to the n minus 1 plus 5, find a to the 4th. So here is our sequence up here. Put 3a1 into your graphing calculator and press enter, then multiply by 2 and add 5. Hit enter 3 more times to get a4, which would equal 59 with this sequence up here. If a1 equals 1, a2 equals 1, and a to the n equals a to the n minus 1 plus a to the n minus 2, for n greater than or equal to 3, find the first 7 terms of this sequence here. So the recursive formula indicates that each term is the sum of the 2 terms before it, up here. Therefore, the first 7 terms of the sequence are 1, 1, 2, 3, 5, 8, and 13. This is called the Fibonacci sequence. And then G, express the series 2 plus 4 plus 6 plus blah, 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 plus 20 in sigma notation. So to express that in sigma, the series 2 plus 4 plus 6 plus blah, 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 plus 20 would equal, we have an upper limit here of 10. We have an initial entry here of 1, then 2i. This summation here would equal 110. And then H, evaluate this summation here. We have k equals 0 would be our initial. Upper limit will be 5, then k squared. So to do that one, we have 0, 1, 2, 3, 4, 5, all squared. We get these numbers here, and that comes out to a summation of 55 for that. One of the most common sequences studied at this level is an arithmetic sequence or an arithmetic progression. Each term differs from the preceding term by a common difference. The first n terms of an arithmetic sequence can be denoted by the following t1, t1 plus d, t1 plus 2d, t1 plus 3d, etc. here. So we get plus n minus 1d. D is a common difference, and t term n equals term 1 plus n minus 1d. The sum of n terms of the series constructed from an arithmetic sequence is given by the formula. Okay, the summation of n would equal n over 2 multiplied by the quantity of term 1 plus term n, or the summation of n would be n over 2 times the in brackets 2 times term 1 plus n minus 1d. So this is how you would find the sum of an arithmetic sequence here. With those formulas, find the 28th term of this arithmetic sequence 2, 5, and 8. So term n equals term 1 plus n minus 1d. So we have term 1 here is 2, and our difference here is 3, and then our n is 28. We want to find the 28th term, so that would be our 28 would be n. So our plug-in here would be term 28 would be 2 plus 27 times 3 here, n minus 1, and then our difference here is 3. So it'll be 2 plus 27 times 3 would be 83. That would give our 28th term on that sequence. J, express the sum of 28 terms of the series of this sequence using sigma notation. So to use sigma for that would be 27, would be our upper limit. K would equal 0, 3k plus 2. That would be here, this would be our 3k plus 2 here. Term 1, which is 2, or 28j would equal 1, 3j minus 1 here. That'd be another way of going at it, would be multiplying by 3 here. 3j minus 1 instead of our 3k plus 2 here. That would be another way of finding the summation. And then k, find the sum of the first 28 terms of the sequence. So to find that, we have summation of n would equal n over 2, term 1 plus term n. Okay, find the sum of the first 28 terms of the series. So we're going to, instead of finding the term, we're going to find the sum now. So here's our formula for finding the sum. Sum of 28 would be 28 over 2 multiply by 2, which is term 1, plus the term n here would be 83. We know that much from finding the 28 terms. We know that the term n would be 83. So now here is our setup there for finding that. And that would be 14 times 85 would equal 1190. So that would be the sum up through the 28th term. L, if term 8 equals 4 and term 12 equals -2, find the first 3 terms of the arithmetic sequence. So term n would equal term 1 plus n minus 1d. So when we plug in here, term n here would be 4, and term 1 plus 7d here. We have a 7d difference here. Find the first 3 terms of this arithmetic sequence. So we jump from 8 to 12 here. n minus 1 would be 8 minus 1 would be 7d. So we need to find our d here in this case. So we're going to start solving here for d. -2 equals term 1 plus 11d. And -2 equals term 1 plus 11d. So to solve these two equations, for d, subtract the second equation from the third. So we're going to subtract the second equation from the third, and we get -6 equals 4d. So -6 equals 4d here. So we're going to subtract this from this, and we get our -6 here, -4, -2, -7, and 11 would be 4d. -6 equals 4d. d will now equal -3/2. Substituting in the first equation gives 4 equals term 1 plus 7 times the -3/2. Thus, term 1 would equal 4 plus 21/2. This comes out to being 29/2. Will be our first term for that one. To solve these two equations for d, subtract the second equation from the third. So we get -6 equals 4d. We're going to do this again. Again, we have d equals -3/2, just to make sure you get this. And then we substitute in the first equation gives 4 equals term 1 plus 7 times -3/2. Thus, term 1 equals 4 plus 21/2 would equal 29/2, would be our term 1. So term 2 would equal 29/2 plus -3/2, which would equal 26/2, which would equal 13, would be our second term of that sequence. And then term 3 would be 29/2 plus 2 times -3/2 would equal 23/2. And then the first three terms are 29/2, 13, and 23/2. M, in an arithmetic series, if Sn, term S, in this case, the term of S would be 3n squared plus 2n, find the first 3 terms. So when n equals 1, S1 equals term 1. Therefore, term 1 would equal 3 times 1 squared plus 2 times 1 equals 5. So our second term here will be term 1 plus term 2 equals 3 times 2 squared plus 2 times 2 equals 16. And then 5 plus term 2 would equal 16. So our second term would equal 11 in this case here, by doing that for our summation in this arithmetic series up here. So therefore, d would equal 6, which leads to a third term of 17. Thus, the first 3 terms are 5, 11, and 17. Another common type of sequence studied at this level is a geometric sequence, or a geometric progression. In a geometric sequence, the ratio of any two successive terms in a constant r is a constant r called the constant ratio. The first n terms of a geometric sequence can be denoted by, and here's our denotation for a geometric sequence. This is the important part here. Term 1 times the ratio n minus 1 would equal the term n. The sum of the first n terms of a geometric series is given by the formula, and then here's our series here. It'll be term 1 times 1 minus r to the nth over 1 minus r. So n, find the seventh term of the geometric sequence 1, 2, 4. So the ratio here would be term 2 over term 1, which would be 2 over 1, which would be equal 2. And then term 7 would be equal to term 1 times r times 7 minus 1. So term 7 would equal 1 times 2 to the 6, which would equal 64. And then 0, find the sum of the first 7 terms of the geometric sequence 1, 2, and 4. So to find that, here is our series here, series 7. We're going to find the first 7 terms of the sequence. So it'll be 1 times 1 minus 2 to the 7th over 1 minus 2, which would equal 1 minus 128 over negative 1, which would be 127. And then p, the first term of a geometric sequence, is 64, and the common ratio is 1 over 4. For what value of n is term to the nth equal 1 over 4? So we need to find which term is equal to 1 over 4. And then 1 over 4 would equal 64 to the 1 over 4 to the n minus 1. So 1 over 4 to the 2 minus n would equal 64, which would equal 4 to the 3rd power. 4 to the n minus 2 would equal 4 cubed. So n in this case here would have to equal 5 in this situation here. And 2 to the negative 2 minus 5, would equal 4. Minus 5 here, so it'd be 4 to the 3rd power here. So the n minus 2 would equal 4 to the n minus 2 would equal n, it would have to equal 5 then. In that case, in a geometric sequence, if the absolute value of r is less than 1, the sum of the series approaches a limit as n approaches infinity. In the formula, Sn equals term 1 multiplied by 1 minus r to the nth over 1 minus r, if absolute value of r is less than 1. The term r to the n is greater than, as r to the n goes to 0, as n goes to infinity. Therefore, as long as the absolute value of r is less than 1, the limit of the series of n as n goes to infinity would equal term 1 over 1 minus r, or s equals term 1 over 1 minus r. Okay, now we're moving right along here. We're going to take a limit here as n goes to infinity for the summation of an upper limit here of n, and k equals 1, and then we have 1 over 2k. This is our formula for this summation as n goes to infinity. When the first few terms, say, are 1/2, 1/4, 1/8 plus ... are listed, it could be seen that term 1 equals 1/2, and the common ratio here is r equals 1/2. Therefore, our summation here will equal 1 over 1/2 over 1 minus 1/2 equals 1. Then when we evaluate a summation here, our upper limit here is infinity, j equals 0, and then our factor here that we're summarizing be -3 to the negative j power. So when the first few terms are 1 over 1, negative 1 over 3, and then positive 1 over 9, and then negative dot 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 are listed, it can be seen that the term 1 equals 1, and the common ratio in this situation here is negative 1 over 3. Therefore, our summation will have this formula here, 1 over 1 minus a negative 1 over 3, which will yield a 1 over 4 over 3, which is 3 over 4 would be our summation there for this one as it goes to infinity. And you can put that in your calculator to check it. And then S here, find the exact value of the repeating decimal 0.4545. Yeah, this can be represented by a geometric series of 0.45 plus 0.0045 plus 0.000045 plus dot dot dot, with term 1 equals 0.45 and r equals 0.01. Since r, absolute value of r is less than 1, our summation therefore will be 0.45 over 1 minus 0.01, and this becomes 0.45 over 0.99, 45 over 99, we multiply through by 100, will equal 5 over 11. So this would be our fraction value for this repeating decimal here. And that is our SAT Math Level 2 Prep Lesson 20, or rather 19, I'm sorry, number 19. Animated PowerPoint math video at AOL.com for course materials and questions. Thank you very much.